So this is chapter 4, section 4, number 13, called optimization. Basically, you're just trying to find maxes and mins. And you've learned two ways to find maxes and mins. In chapter 4, section 1, you learn that maxes and mins occur at critical points and endpoints. So therefore, you find your critical points and you find the value of the function at your critical points and endpoints. The biggest value is the max, the smallest is the min. So that was the first method. Then you learned a new secret. If you have one relative extrema on a continuous function, then it's also an absolute extrema. So those are the two methods we're going to use. So looking at this question, what are we trying to find? We're trying to make this sum as small as possible. In other words, we're trying to minimize that sum. So I will call that sum, I don't know, what do you want to call it, z? You can call it whatever you want. But in essence, I want to minimize z. So the question is, where do minimums occur? Critical points and endpoints. So I need to find the critical points. So in other words, I need to find the derivative. So let me find the derivative, excuse me, and that will be how I will show you. I can't do it because I have two variables. That's no bueno. So in these problems, you will notice you will be able to find a second equation. They give you one right here. XY equals 12. Oftentimes on these, you're going to have to come up with the equation. Now I have a choice. I can solve for y or I can solve for x. In this case, it really doesn't matter because it's easy to divide by either one. Sometimes it's easier to solve for one or the other. In this case, it doesn't matter. So in place of y, I'm going to place 12 over x. So we have z equals 2x plus, and I'm going to move the x to the top and make it -1 power. So when I take the derivative, it's easier. So I take the derivative y to find critical points. Why? Because max and mins occur at critical points and endpoints. So derivative 2x is 2. And this, I bring the -1 in front and decrease the power by 1. So now I have the derivative is 2 minus 12 over x squared. Well, I don't like that. I could actually solve at this point, but let's get a common denominator. So I multiply this by 1, and now I have z is 2x squared minus 12 over x squared. Okay, let's keep going. How do I find critical points? It's where the derivative is 0. Well, when is this 0? When the numerator is 0. So I set the numerator equal to 0, add 12 to both sides. Whoa. Add 12 to both sides. Divide each side by 2. Square root both sides. Now let's read the original question. Key word, positive numbers. So we can ignore the negative. We don't need to deal with the negative. So notice that's the only critical point. Oh, I'm a liar, liar, pants on fire. When z prime is undefined, it's a critical point. When is a fraction undefined? When the bottom is 0. When x squared is 0 or x is 0. Are those two critical points? And the answer is no. Remember, critical points cannot be endpoints. 0 is an endpoint. How do I know 0 is an endpoint? Because x and y are positive. In other words, x is greater than 0. 0 is an endpoint, therefore not a critical point. So why is that so critical? Because I have only one critical point. If that's the only relative extrema, it's also an absolute extrema. So I'm excited. So let me test to see if that is a relative extrema. So radical 6, what is that? 2 point something, right? So I'm going to pick 1 here and 10 here. Now, you can pick any number that's between 0 and 6, and I guess infinity is on that side. Any number. Now, let's plug that into the derivative, 1. So it's going to be 2 minus 12, that's negative. The bottom's always positive, so negative. Let's plug in 10. 10 squared is 100, 200 minus 12 is definitely positive. So we're pretty much done. So let me explain what you would write out. You would say z has a relative minimum at radical 6 because z prime changes from negative to positive at radical 6. Then you say, since this is a continuous function and it only has one relative extrema, therefore it's also an absolute extrema. So there's an absolute min at x equals radical 6. So you want it as small as possible. So therefore you want the x and y coordinate. So we found x is radical 6. How do you find y? Well, you put radical 6 there and you find your y. And that's how you would do number 13.